Welcome back, let's continue. In the previous video, we talked about descriptive statistics and inferential statistics. And I was about to give you a couple of examples related to these two, but time ran out, so let's continue. Here's an example of descriptive statistics. I took this from our textbook, and here we are. It's about teens behind the wheel and about use of cell phones. In the left-hand side, we have 84% of teens have cell phones, 16% don't. There goes a set of data. If you go over to the right-hand side, we have a little bit more complicated data set. 83% of the teens admitted they have talked on a cell phone while driving. 76% of the teens admitted they broke the law. 68% admitted they texted, and so on and so forth. That's a little bit more complicated compared with the left-hand side. We have just 84% and 16%, just those two. So we did not really need any kind of graphical information. 84 and 16, easy to see. But here on the right-hand side, if we simply explain everything in a paragraph, talked on a cell phone, 83%, broke the law, 76%, and so on and so forth, it's going to be a little bit difficult to understand, especially for visual people. So what do? One way to handle it is to present it like this in a bar graph, which is embedded inside this picture of this car in the back window. That kind of thing is called descriptive statistics. This bar graph is one mechanism to describe some data values that we collected, and that kind of thing is called descriptive statistics. Of course, there are a variety of other ways, but bar graph is one of those. Oh, by the way, the picture of this car is a part of descriptive statistics too. It's hardly mathematically, I know, but it helps people understand this is about not just teens or not just cell phones, but it's about driving. So even pictures are related to presentation of data. That kind of thing is called descriptive statistics. And we have sources for these kind of things. The National Organization for Youth Safety, Allstate Foundation online survey of 605 drivers, blah blah blah, and the date, things like those. But they didn't say anything further than just the source and number of drivers interviewed. Sometimes even the number of drivers interviews are withheld as well. That usually is not very good, but sometimes that happens. Now let's move on to the next example. I labeled it as an example of an inferential statistic. What is the difference here? What do employers look for in a seasonal employees? And positive attitude and eagerness, 39%, ability to work, the schedule required, 28%, and so on and so forth. And what we have a pie chart instead of a bar graph. And then we have a picture of paycheck here instead of a picture of car. So far, everything is just descriptive statistics, just a way of presenting data, a different way of presenting data. Pie graph instead of bar chart, just another type of picture versus first type of picture. No difference here. Let's scroll down just a little bit. Now things will become a little bit more interesting. Snagajob.com survey of 1,043 hiring managers. Margin of error is plus or minus 3 percentage points. The last one, margin of error, how is that coming? That is actually coming from a kind of computation, and that's what the inferential statistics is all about. Now, I cannot tell you how this was calculated at this moment because inferential statistics requires quite a bit of preparation. We didn't even begin yet. If I simply interpret this survey data in the end, this is what we get as a matter of fact. For example, positive attitude. and so on. What is the result? We have 39%. Well, does that mean absolutely 39% of all hiring managers are looking for positive attitude and eagerness as their number one criterion? Well, probably not, because according to the survey of 1,043 hiring managers, we got 39% yes, but there are many more than 1,043 hiring managers out there. So this is actually coming from a sample study, just sample of 1,043 hiring managers out of, well, many more, maybe millions. And what does it say? Based upon, what do you call this? Based upon the sample study mechanism and also sample size, we have 39% plus or minus 3% point of margin of error, generating 36% to 42%. So what did he end up with? Even though this study or this picture over there gave you just one number, 39%, after some mathematics, which we call inference, we ended up with an interval that begins from 36% and ends at 42%, 36% to 42%. And this kind of interval is called confidence interval, and finding out such confidence interval based upon appropriate confidence level is an example of an inferential statistics. There are, of course, other kind of examples too, but I just wanted to show you one example, and here's one. Let's go back to the previous example here. We have all those nice data and go to the source. We have source, and then we have 605 drivers ages 16 to 20 and so on. But this one did not discuss anything about margin of error, which means they did not conduct any inferential statistics in the first example. Inferential statistics is, in general, more inclusive than descriptive statistics. Some part of descriptive statistics is required as a first step or a stepping stone, but beyond that, we have to do some mathematics and do some inference or hypothesis testing. Okay, let's continue. Let's continue upon our textbook, and then we have to talk about some terminologies, important terms. And here, important terms: population, sample, variable, data value, data, things like those. We have to use these kind of terms in the latter part of our textbook, latter part of this course. So you have to know all these. Among them, some are more important, some are a little less important, and of course, I highlighted those important terms with appropriate colors. What is a population? It's a collection of individuals, objects, or events whose properties are to be analyzed. So in a previous example like these, it's all hiring managers in the entire country. Or if you're looking at just DFW area, then entire hiring managers of DFW area, and that's a huge number. So big that it's difficult, if not impossible, to analyze directly. So what do? We take a sample. A subset of a population is called sample. And in the previous example, we took a subset of 1,043 hiring managers, was it? Yes. So sample tends to be large, but not super large. It's a subset of a population. Now, what kind of subset is it? Well, good question. You have to select the sample cleverly, otherwise you're going to get something pretty bad, which we call bias. Now let's move on to the next example. A variable is a characteristic of interest for individual element of a population or a sample. So one element or one hiring manager, for example, may have a number of different characteristics. In this particular example we saw in the second here, there's only one question: what do employers look for in a seasonal employees? So they're looking for just one variable here, and then the variable took different values here. And, well, okay, and in that case, just one variable. Let's go over to the previous example. In that case, we have many different variables. Talked on cell phones, broke the law, texted, scrolled iPod, upset driver. All these are different questions. And they are all different characteristics. They are different variables. So variable does not mean really a number or X, Y, Z kind of things as we have done in algebra classes. In statistics, we need different types of definitions. So variables in statistics means something. Variables in statistics is definitely different from variables in algebra. Data value, and the value a variable is associated. And data, the set of values. As a matter of fact, data, the term data is a plural of datum. So data value could be written as just datum. But let's stick to the way our textbook is written, data value. Okay. An experiment, a planned activity that yields a set of data. Sometimes we do experiments, sometimes we just do survey. And if we can control everything, then we do experiments. But very often we cannot really control everything. For example, if we have to just take a survey about what are the important characteristics or important traits you're looking for from seasonal employees kind of thing. And it's a survey or an observation, not an experiment. But for example, if you want to do some medical research, then typically we take some volunteers and then divide the group into two randomly selected groups, experiment group and control group, and run an experiment and then compare those two. And one set of people get a drug, experimental drug, and the other people get placebo and compare the result. Those kind of things are called experiments. And what kind of statistics are coming from the experiment? What kind of statistics are coming from surveys? Those are a little bit different, because survey we just deal with one sample and variable. But experiment we are dealing with one variable, yes, but we are typically dealing with two samples, one experiment group and one control group. I talked a little bit too much about future topics. Sorry about that. I just wanted to explain these terms. Now here are a couple of very, very important terms: parameter and statistic. Parameter are numerical values associated with population. That's why I color-coded in blue. Statistic is a numerical value coming from sample. And in order to distinguish them even easier, mathematicians typically use Greek letters for population: mu, sigma, pi, and things like those. Pi's can be rather difficult because in many situations it means number pi, 3.14 something. But in statistics, very often it means probability of a population. For statistic, we typically use Roman characters, Latin characters, MSP, things like those.